Alright, okay, so I'm starting this over. So my whole iterative approach ended up in disaster, so I'm going to try again. I have a new strategy. No. Alright, what am I doing? So if not candidates, I go here and I look at candidates and I look at get candidates, and basically as soon as you get the candidates, you want to so if you don't have any candidates and your board's empty, then you pre-populate the candidates, and then you want to get like the first candidate. So you pop off, get that candidate, and I would say add it to the stack. And I mean, yeah. So you do candidate equals candidates.pop, and then it'll append this to my stack. IJ candidates. So that in case we want to go back to this, but yes, we get our current candidate, and I would say set it equal to that current candidate. Now what else do we want to do? So this is, if we don't have candidates, it's going to do this. Or do we want it to always do this? I think we always wanted to do this. So it's like, as long as you can get some candidates. I gotta do something different. I gotta do if candidates equals to none. Do this. Okay. If length of candidates equal to 0, if length of stack, if not stack, then do this. So basically what's going to happen is, if you no longer have a stack, return false, you're done. If you still have a stack, but your length of candidates is, then you could pop in the stack and get the original candidates from it. And then continue. Else, if the length of candidates is not 0, get your current candidate, update your stack with the candidates, so your board equal to that candidate. And then set also another thing is that this is else. What's else for this statement? It means that I don't think I need else. So let's think about what this will do. Let's see, it might work. Okay. So what this will do is, so get candidates will just get all the candidates that you have, a list of candidates. So you start here with this rows, calls, and subs, and this will give me basically add each element to certain rows, to certain columns, and to certain subboards. That way I can check and might get candidates basically if it's not in that row, not in that column, and not in that subs board. And then you start with IJ, and you start with it equal to empty, or not empty, but it's equal to a dot. Now this is if it is equal to a dot, then you want to check this. If it's not equal to a dot, then you just run this code, right? Yeah. This should be else, because you only want to run this code if this is false. Yeah. Yes, that's right. Okay, and then, okay. So, okay, but if boards is empty, then you go to candidates, you check candidates. If candidates is none, which it will be initially, then you get the candidates, and then you check the length of candidates, which will probably not be 0. If this is not 0, you will use one of the candidates and append to the stack the updated candidates, and then set candidates equal to none, and then what's going to happen is it's going to, oh wait a second, you want to go to the next thing, right? Oh yeah. So actually, do you want to run this code? Like so. Okay, so you now run this code, and then it'll go to the next one, and if it's equal to none, it'll go to here, it'll add candidates, blah blah blah. Now you might get to a point where, oh, you know what? You have to update candidates. That's right. You have to update candidates each time. So, I mean, that's pretty easy though, right? I just do this. I just have to do rows. Although it's not super easy, because then what if I have to remove it if I pop from it like this, right? But how do you remove the previous candidate? Shoot. I guess the solution is to just use the board. Yeah, okay, I know what to do. So just use board here, and then use the current board to compute the candidates. Okay. That means that basically I'll do this every single time. Yeah, this will work. So now it's going to get these, it's going to iterate through these, it's going to check board, and then it will add it to it, and then it will do this. Voila, that should work. And here, if candidate none, okay, so candidate won't be none, so you always call get candidates. If length of candidates is 0, so if length of candidates is 0, that means, I don't know what that means. Yeah, I have no idea what I'm even doing most of the time. Right. I spent, what, an hour and 20 minutes on this problem? It's a hard problem. So I'm still trying to convert this from what I had before, which was a recursion to an iterative approach. I love iterative approach because they're more intuitive, so I knew that once I get it set, it would be more intuitive. So let's think about what's going to happen here. So each time we go through the Sudoku solver, we take our current board. Okay, we have create an empty stack. We set our candidates to none, and then we're going to iterate through this board, basically, until we get to the end of the board. Now the main goal is that anytime it hits an empty thing, it's going to check, well, if candidates is none, then we're going to get your candidates for our first time. And then probably the length of candidates will not be 0 then. I mean, if it is 0 and you don't have a stack, then you're going to just return false. But, this will probably not be 0, so you'll probably go down to here, you'll get your candidate, you'll append, You update the board, and you go candidates. And then you'll move the J, and this will move the I whenever the J is 0, so that you're moving through the board by moving through each row. So you start with one row, and you go through each column in that row. Then you go to the next row, you go through each column, and you go next. So it's like starting from the upper left corner and moving to the bottom right corner. And then, okay, so it'll do that, and then the thing I'm really wondering is what will happen once we get to a situation where we run out of candidates. Then it'll like check, okay, there is a stack, then we want to pop from the stack, and we go back to that I, and you'll go back to that J. So then when you go to, wait a second though, if you do that, don't you need to set, I think there's two options to do here. Either I think you just set it equal to empty, and then, yeah. You just do board I, J equals to, so just reset it back to an empty block, and then continue, so it's going to go back to this IJ with these candidates, so it's going to be empty. The candidates will not be none. Lambda candidates could be 0, but it might not be 0. If it's not 0, you're going to go down to here, it's going to get the candidate, it's going to append this updated one, and it's going to go board, and it's going to start iterating back through. Alright, back to debugging. Oops. Oh my gosh. I had to go back to this thing. Wait, where's my solution? So it's true, right? Yeah, it should be true. Okay, it returns false. That's not right. It goes back to 0, 8. What? Oh shit. Why does it do that? Alright, well, let's print out the stack. Let's see what the stack looks like at each level. We have an empty stack, We add, what the fuck? Why are get candidates empty? The only candidate is a 4. I don't know if I believe that. No, that can't be right. So we start with 0, 2. So 0, 2 is the first empty place, which I think is true. Yeah. So 0, 2, you get this default dictionary. 0. Oh, it just fills it in. Okay. Oh, you know what? I see what the issue is. I gotta label these as different variables. Like maybe row and call, and then down here I use these row and call, row and call. Okay. That's definitely more reasonable. I'm going to assume that it's working. This reminds me that, okay, the output is correct. This reminds me that I need to make sure that I test my code for each part. Before I just go and I'm going to run this test. So it actually does pass. Not entirely surprising, although, yeah, I had to fix up a couple of errors. Okay, so let's go over why this works. So, okay, so this is using the iterative approach for a Sudoku solve. So the really cool thing is, and that's one thing I could do, so I should print out, before I return true, let's print out the board so you can see I can see the actual solution. So this is the actual solution. So yeah, it fills in the board. So what's going on is, okay, so the first part of this problem is creating this thing called get candidates. And get candidates is a simple function which is going to return a list, an array of all the candidate digits. And it does it by basically iterating through, taking the current board configuration, because the board is going to change through the process of solving the Sudoku when you try different values. So you're going to change the board, take the board, you fill in because the Sudoku board depends on what's in the rows, what's in the columns, and what's in the subboards. So you fill those in as sets or whatever. And then, and this R divided by 3 and C divided by 3 floor division is just going to basically return you, the subboards are going to be 0, 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2, 2, 0, 2, 1, 2, 2. Those would be like the coordinates of all 9 subboards. Because the floor division will basically, if you do 1 floor division 3, you get 0. 2 floor division 3, you get 0. 0 floor division 3, you get 0. But once you go to 3 floor division 3, you get 1. And then 4, you get 1. And 5, you get 1. Anyway, and so here candidates equals, so candidates is empty. So then you fill in the candidates by iterating through all the digits and seeing if the digits are not in these rows, columns, and subboards for the specific row and column that we are looking at. And you fill in the candidates. Okay, so it gives you candidates, and then here to solve the Sudoku board. So using a stack, instead of using recursion, you're going to using a stack. And the whole point of this stack is to basically you iterate from the top left corner of the board. So iterate from the top of the left corner, and then you iterate through it, going to the right. And then once you reach the end of a row, I guess, you go to the next row, and you just keep going, iterate to the bottom right, from the top left to the bottom right. And then basically, if you end up getting somewhere where basically the length of candidates, if you run out of candidates, is 0, then you are going to pop from the stack and backtrack to that I and j and start over from that I and j with the new set of candidates, and like take the first name from your candidate. You always pop from the candidates. So like for this one, it'll fill it in. It will iterate through. Whenever it sees an empty cell, and a candidate says none, it's going to get candidates. Candidates will not be none if you're popping. So once you start popping from the stack, you're just taking the current candidates list, how it currently is. But whenever you add something to the board, a candidate, you pop that candidate from the candidates list and update the stack. Yeah, so even when you pop from the stack and you get an I and J, it's going to reset the board to empty, and it's going to continue, so it's going to go back up here, and the board is empty now, but candidates is not none. The length of candidates is not 0, so it's going to go here. It's going to use this candidate from the candidates, append it to the stack, your I and J with the updated candidates, and then put this candidate with the board, and then set the candidates to none. But that only matters for when you go to the next iteration. And this will not be empty, blah blah. You'll go until this is empty again, and then you'll see if the length of candidates is still 0. Wait a second. So okay, originally you hit a candidates that was the candidates was 0, I think, and that's when you want to go backwards on the stack. Yeah, and if you don't have a stack to go to recurse with, then yeah, you're out of attempts. The stack has all the previous guesses that the program has, or all the values that the program has guessed prior. Okay, so then okay, so yeah, so basically it sets the candidates, and then it's going to go back to check the length of candidates is 0. If it's 0, it's going to go backwards. Eventually, it'll probably return to this board that was empty. And it's possible that the candidates will be set to none, and the board will be different. So when you do get candidates, it may actually give you candidates that is not empty, the length is not 0. Okay. And then this right here is how you iterate through it. So J is going to increment once J, so it's going to start at 0, and it's going to go to 1, 2, 3, and then once you go to 8, you have 8, and I is still at 0, but once J goes to 9, it's going to reset to 0, and it's going to increment I, so it'll go to 1. And then once it goes to 18, it'll increment I to 2, and J will be equal to 0 again, because so it's going to be modulo 9. Sorry, it's not ever gonna go to 18, my bad, because it's gonna restart at 0 and then go back to 9. Yeah, that's right. And it returns true if you are able to go through all of the able to get through this whole thing without not having a stack to iterate back through.